Hello friends, as we have got in the last class, what do you mean by a function? Now that is geometrically how we can represent that I have shown in the screen. See, I have taken one domain function, that is z plane, and another one is w plane. I have defined a mapping there such a way that all the elements of z plane is corresponds to an element of w plane, or in other words, all the elements of the domain, it is connected to uniquely the range set of w plane, and that we can write a function as w equal to f of z. After studying function there, very important concept in the complex number is calculus of complex numbers, that is limit of a function. As you have studied in set of real numbers, the limit of a function, we will also study in the set of complex number. The limit of a function f of z is nothing but limit of as z tends to a finite number, say it is 0 or a, then the function value f of z tending towards to a number, that number is called limit of the function. That is one way you can define it as in set of real numbers. In the same manner, or in another words, you can also define the limit of a function by using epsilon delta definition. By the definition here, for a given complex number f of z, we are defining with the help of neighborhood of a point here. A given a function f of z, you are taken a neighborhood there, say it is z naught, except possibly at the point z naught there, the number w naught, a real number, is called limit of that function when the numerical value of, that means here modulus of f of z minus w naught is less than epsilon, whenever modulus of z minus z naught is less than delta, where epsilon and delta are small positive quantities. Now how it is going to be defined, as it is shown in the figure, you may observe that here. In the z plane, you have taken a set of complex number there. In the w plane, you have taken another set of complex number. You have defined a mapping there, w is equal to f of z. Then how that limit concept is going to be defined there? It is there, that is clearly it is observed there. I have taken a point z naught, that is, which is a small, I have taken a small radius there, represents a circle there, small radius, and it is a corresponding element in the w plane that I have denoted by an epsilon there. So geometrically we can understood like this here, as I have shown in the figure that. Then as you have studied in set of real numbers, limit concept there, we have also properties of complex numbers. That is, suppose I am considering two functions f of z and g of z there. Suppose limit of f of z as z tends to a is tending towards to a finite number, say I have taken it as a, and limit of g of z as z tends to a, I have taken it as b there, then it satisfies following properties. 1. Limit of f of z plus g of z is a plus b, or we also say that limit of f of z plus limit of g of z, we will write it as a plus b. In the same manner, limit of f of z minus g of z is equal to limit of f of z minus limit of g of z, or we can write it as a minus b. Similarly, in the multiplication, limit of f of z into g of z is equal to limit of f of z into g of z, which is equal to ab. In the same fashion, limit of f of z divided by g of z is equal to a by b, provided the denominator limit g of z is not equal to 0. That means b should not be equal to 0, so that it is going to be defined. Now, there are different types of theorems in the limits topic. Now, first theorem that I am going to say here, you have taken that limit of f of z, say it is, I will write in terms of real and imaginary part, f of z is equal to u of xy plus I into v of xy. Now, I have taken a point there, z naught, which is known to you, x naught plus I y naught plus, and w naught is equal to u naught plus I v naught. Then, by the definition of limit of f of z as z tends to z naught is equal to w naught when it is holds good, or we will say if and only if limit of u of xy is equal to u naught and limit of v of xy is equal to v naught. That means real part converges to or goes to real part, correspondence is real part, and imaginary part corresponds to imaginary part of that number. So, this is the first theorem that we can observe here. Now, all the time limit may or may not exist. Again, I will repeat, the limit of the function may exist or may not exist. See, here I have given an example to understand that. Here it is. Say I have taken an example of limit of a function z tends to 0. Function is z by z bar. Say in the denominator it is z bar. It is not clearly visible there. You just take it as z bar. What do you mean by z bar? As I have explained you, z bar is complex conjugate. That is, if z is equal to x plus iy, z bar is x minus iy. Now, such a function limit I have taken here. Now, if you are taking the limit of that as z tends to 0, as usual manner, I am writing z is x plus I into iy divided by x minus iy. As you know that limit of the function, if it exists, then it should be unique as in real number, as you have observed that. Here also, in the complex number you have two part, real part and imaginary part. So, I will divide it that. Now, we will observe the real and imaginary part discussed separately in the next class. Thank you.